Welcome friends to our YouTube channel where we are presenting lessons in mathematics. So in this presentation, which is lesson number 4, we want to look at questions from the past papers. Okay, so we have about 3 questions from the past papers that we are going to do together. Later on I'll give you an exercise. So these questions that we are going to do as examples, I'll just subject them to the camera so that you are able to copy. Okay. Okay, so I hope you have copied those questions. Please make sure you write them down so that as I work them out on the board, you're able to refer to them. Okay, so the first question is the first question that appears there. I might just try to show you again. This is the first question that we are attempting. Okay, so we are saying in this diagram, in the diagram below, A and B are points on the on latitude 60 degrees. All right, 60 degrees north. So here there is 60 degrees north. Here there is 60 degrees north. Okay, this is question 3. Take note. All right. While C and D are points on latitude 60 degrees south. Here, maybe I can even write it here. Let's say in most cases we tend to write there, but let me write 60 degrees south because I don't have enough space here. This is 55 degrees west. Okay, so we have a 60 degrees south there. Okay. Then take pi to be 3.142 and the radius to be 3437 nautical miles. So if that's the case, can we calculate the distance BC? BC along the longitude 60 degrees east in nautical miles. So we want the distance BC. So Roman numeral 1. So we want to find the distance BC. Remember we said if it is nautical miles, all right? If it is nautical miles, you can easily use this. If it is along a circle of longitude, that's what you can use. So BC, nautical miles, you can easily use this, or you say BC is equal to theta over 360 times 2 pi r. This is a multiplication sign. Either this or that will give you the answer. Okay, so I think we can go for this. What is the theta? Theta is the difference in latitude between B and C. So we're interested in the angular difference there. Alright? Now, when you look at the latitude for point B, 60 degrees north. The latitude for point C, it is 60 degrees south. So the difference in longitude is found by adding because they're on different sides of the equator. So in this case, you're going to say 60 degrees north plus 60 degrees south. So 60 plus 60. We get 120. So here we have got 120 degrees times 60 degrees. Alright, so BC is equal to, okay, so here I've got 0, 0, this by that, it is 12, okay, so we have got 7, 2 nautical miles, so 7,200 nautical miles is the distance there. If you want to apply this, you will still get to this, especially after rounding off. Okay, so that's the distance that exists between B and C in nautical miles. So if it were kilometers, you'd apply this one, but just change here. Where there is this radius, you put the 6370 kilometers. Okay, so that's Roman numeral 1. Then Roman numeral 2. I hope you're able to follow. We are saying a ship sails from C to D, all right, in 12 hours. So time is equal to 12 hours, all right? That's the time. Time is 12 hours. Okay, let me write something that is very visible. Time is equal to 12 hours. All right. The question is, what is the speed? So we want speed now. Okay, here we don't know, but this speed is in knots. Now, what is a knot? A knot simply means a nautical mile per hour. Okay, so 1 knot simply means 1 nautical mile per hour. Okay, so for us to find the knots, the speed in knots simply means we must find the speed in nautical miles per hour, because 1 knot is equal to 1 nautical mile per hour. Okay, so in this case, what we are going to do is we recall the formula for finding speed. So we are saying speed is equal to distance, all right, over time taken. Okay, so now we are saying this ship sails from C to D in 12 hours. All right, then what is the speed? So we say that for us to find the speed, we need 2 things. We need distance as well as what? Time. Okay, here we have our distance, which is 12 hours. How about we have our time, which is 12 hours. How about our distance? So the distance here is missing. All right, so we are saying D here is not there. All right, it's not there. Let me not put that. It's not there again. So we must find distance in order for us to find speed. Okay, so now for us to find distance, you look at the where the points lie. In this case, C and D lie on the same circle of latitude, 60 degrees south. So you must find the distance that exists between D and C. So you're going to say distance between DC is equal to theta over 360 times 2 pi r cos x. Or you can use the other notation, but it's fine even that one. So we are saying that's a formula that we are going to use to find the distance. Because for you to find the speed, distance and time should be found. So now, what is our theta there? Our theta is the angular difference here. Alright? Well, the difference in longitude between D and what? See, you can see that the longitude for D is 60 degrees west. The longitude for B is 60 degrees east. So these two are on different, they are on opposite sides, or different sides of the Greenwich meridian. Alright? So this one is on the western and this one is on the eastern. So how do we find the difference? We find the difference by adding. So we are going to say DC is equal to DC is equal to 120, because when you add 60 plus 60 you get 120 degrees, alright, over 360 degrees by 2 times our pi is 3.142 by our radius, we take 3437, alright, times cos. What is the angle of latitude here? The latitude here is 60 degrees west. So you're going to say cos what? 60. So you have to punch this one. Okay. You have to punch. Okay. You have to punch and see the kind of the answer that you are going to get. Okay. So we are saying, take note, the theta is the difference in longitudes. Alright? Then apply this formula. Okay, so this is what I found here. 3, 5, 9, 9.68, 46. Okay. About 6, 6, 6, 6. The 6 and 7, something like that. Alright? So we are saying DC is equal to, you can round off these to 3 significant figures. Or if you don't mind, you can use it like that as you find the speed. And I think the best is we round off. Okay. The best is we round off. Okay. There are times when you round off, sometimes the answer tends to be slightly different, but it's fine. We can still round off. So I've got 1, 2, 3. We take this one as 1. So 1 plus this, we get 10. So you take a 1. So 1 plus this, we have got 6, 3. Alright? Then since there's one digit, you put this. Put 1 0. So you have got this in nautical miles. So I'm sure if we were to use the other approach, you arrive at that. Even, I think, without rounding off. So what we are saying is, the distance now between C and D, it is 3,600 nautical miles. Okay? That is the distance. So what we are going to do now is to find the speed. Okay, so we are saying speed is equal to, what is our distance? This is our distance now. 3,600 nautical miles divided by time taken is 12 hours. Okay, so 12 into 36, it is 3. Okay, so which is the into 0, you have got 0, into that, you have got that. So you have got the nautical miles per hour. Okay, that is our speed. Remember, I've said 1 nautical mile per hour is 1 knot. Okay, meaning that 300 nautical miles per hour, it is 300 knots. So therefore, our speed is equal to 300 knots. There's that 1-to-1 proportion. Okay, that is our speed. Okay, 300 knots. Okay, so I think this question has been tackled. The first one was about finding the distance BC, which we did. Then the other one was about the speed. So if the distance is not given, give the distance. Whether it was along a circle of latitude or a circle of longitude, as long as you apply the correct formula. Okay, so we can go to the second question. Okay. Maybe we can erase this one. That we don't get mixed up. So let's look at the second question. Okay, so the second question, we've been given the points. We are saying point A is 15 degrees north, 40 degrees east. And point B is 35 degrees south and 70 degrees east. C, 85 degrees south, please, this is south, and 40 degrees east. Okay, these are the 3 points that have been given. So the points A, B, and C are on the surface of the Earth. So we take pi to be 3.142, then the radius is 6370. Okay, so the first question is, calculate the distance AC in kilometers. So now, for you to be able to calculate these things nicely, even by this you can tell what is happening. When you look at point A and C, you realize that A and C share the same longitude. If it is in this case, maybe this line. Alright? But when you look at B and C again share the same latitude of 35 degrees south, which could be down. So sometimes to make your job easy, it is advisable that you draw these, you label these points. So you can see that with regard to the longitude, we don't have a longitude on the western part. Alright, so we just need just one longitude here. So we can have this. Then with these latitudes, we just need 2 circles of latitude. Why? Because I have one on the northern part and another one on the southern part. This one and this one, they are the same. So you need this. So this one on the northern part, we can call it 15 degrees north. Alright? Then this one that is down here, we can name it as 35 degrees south. Alright, please take note. I'm able to differentiate these numbers. Alright, let me try my best. Okay, 35 degrees south. Okay, now again we are seeing that we have got 2 longitudes, 40 degrees and 70 degrees. Now these longitudes, if you were to have a line here, it will be centered at 0. So from 0 you keep on increasing. So if from 0, okay, if you have 0 here, alright, so the longitude will keep on increasing. If you have got 10 degrees and 15 degrees, all of them they are on the eastern, meaning that this one will have 10 degrees, then the second longitude will have 15 degrees. You increase, alright, as you go outside. Okay, so we take note that we have 2 longitudes here, 40 degrees and 70 degrees. All of them, they are on the eastern part. So we can put up another, I think another longitude here. Okay. Actually, that's how you sketch. So between 40 and 70, which one are we going to put here? Or how? What are we going to name this longitude? Are we going to name it as 40 degrees east or 70 degrees east? Now, because 40 is smaller than 70, so this one will be named as 40 degrees east because it is closer to 0. Okay? So this one is 40 degrees east. Then this one should be 70 degrees east. That's how you label these things. Okay? Then now we just put those points. We are saying for point A, latitude is 15, which is this one. The longitude is 40, meaning that it must lie on this latitude and this longitude. So you put your A here. You can put, say, this is point A. Alright? Then point B, it is 35 degrees west. So it must lie on this latitude, but the longitude is 70 degrees, meaning that it must be outside, not here. So this point here is point what? We can call it point B. Okay. Then C, the same latitude, but the longitude is 40. So this one should be what? C. Okay. So this line we can remove it. We're just using it to illustrate. So that's how those points do appear on the surface of the Earth or on that model. Then the question now we are saying, calculate the distance AC. So you look at A and C. So A and C, they are sharing the same longitude. Okay? So you are going to say, this is B. Okay, Roman numeral 1. So we are saying for us to find AC, AC is equal to theta over 360 degrees times 2 pi r. This is the formula that we are going to use. Okay. Okay. So now you are going to say AC. AC is equal to, look at A and C. So we are saying they are sharing the same longitude, meaning that angular difference, it is a difference in latitude. So this is 15 degrees north, and that is 35 degrees south. So the difference here is 35 plus 15, which is 50. So you have 50 degrees over 360 degrees times 2 times our pi is 63670 because it has to be in kilometers. So we have got 6370 kilometers by sorry, our pi here is supposed to be 30.142. Okay, so that is our pi, but our radius is this one. Okay, so I've just put the pi here, doesn't matter. Okay, so you multiply here. Okay, so we have got 559.59. There is 4. There are some numbers there. Okay, so you can round off this to 3 significant figures, right? So 1, 2, 3. You chop here and consider this one as 1. 1 plus 5 is 6. So I've got 5, 5, 6. But there's one digit before a point, so you fix a 0 here. Okay, this is in any case. All right, so that is our distance, 5,560 kilometers. That's the distance that exists there between the two with regard to the information that we have been given. Okay, I hope we have tried our best to explain that one. All right, Roman numeral 2. You have A again. So we are saying an airplane takes off from point B. So it takes off from this point B and flies due west. So from here it flies due west, either to the left hand side, on the same latitude. So the latitude there is the same. Okay. Covering a distance of 900 kilometers to a point Q. Good. So now, A, calculate the difference in what? Longitudes between B and Q. So we are saying this airplane takes off from this point due east, okay, to a point Q, but the distance between B and Q is 900 kilometers. Okay. So the question is, calculate the difference in longitudes between B and what? Q. So here, what will help us is, we are saying this plane takes off from this point to some point Q on the same latitude. Okay. So since they are on the same latitude and they are talking about distance, so you must recall now the formula for finding the distance between 2 points on the same latitude or lying on the same circle of latitude. We are talking about the distance and the same latitude here. So we are saying the distance that will exist between B and Q, right, is that of the distance of points on a circle of latitude. So you recall that formula. Okay, you recall the formula. You will say theta over 360 degrees times 2 pi r cos x. All right, you can use the other formula. So now, okay, here we will stick to this because it is kilometers. So we've been told that the distance that exists between these 2 points, B and some point Q, is 900. So here we'll say 900 Ks. All right. So now look, if you want to find the distance that exists between B and C, for example, both B and C are on the same latitude, it means the theta is the difference in longitude, right? So this question, when they're asking us to find the difference in longitude between B and Q, they want you to find theta in short. They want you to tell them what theta is. Okay. So now we're going to say, okay, theta over 360 degrees, okay, times 2 times 3.142 times 3437 cos times cos what? The latitude here, 35. Okay. So the base is, okay, so here you might introduce a dummy one even there. But take note here, we are finding the distance in kilometers. Actually, even the radius given there, it is in kilometers. So even here we use kilometers. Take note. Okay, so here we're supposed to put 6370. Okay? So the best way of doing this is you can multiply everything here. Okay? You multiply everything here. Okay? So you have got in here 900 kilometers is equal to, so you can multiply everything here from 2 up to cos 35. Okay, so when we multiply, this is what we are going to get. 34,666.2001701,196, and there is times q there. We'll put a q at the end. Everything should be divided by what? 360. Alright, degrees over 1. Now, what we are going to do here, so for you to find the q, you do cross multiplication. You're going to say 900 times 360. So I want us to go straight. Alright? So how you're going to get this q is, you say 900 times 360. So you say 900 times 360 degrees. Whatever answer that you're going to get, you divide by this. So this should be divided by 34,666.2001701,196. That's how you get our theta. Actually, this is theta, not q, but theta. Alright? That's how you get your theta there. Okay, so you have 900 times 360 divided by 34,666.200,170,196. I hope you have found the answer. Let me erase the top part. Okay, so when you work out that, you find that our theta is equal to 9.34627,961,589. Okay, that is our theta. Okay, that is our theta. Okay, so we are going to, okay, so take note here. I think we're a bit quick. When you multiply here, the correct figure is this one that I have here. Okay. Correct figure is 32,789.9027130076. Okay, times theta. So we are saying how you get your theta now. You're going to multiply this by that, which is this one. They divide by this number. Okay, so here divide by the same number, which is 3278 9.9027130076. Okay, so now when you work out that one, again, even this one somehow will be slightly affected. Okay, these are just minor issues. Okay, so here the value is 9.88109. But though there are some digits there, it's fine. So this is what we have. But now, so our theta will be equal to, for degrees, you round off to 1 decimal place. Okay? So we are going to say 1 here. After a point, you count here and consider this. Okay? As the 1. 1 plus this, you get 9. So you have got the 9.9 degrees. So this is the difference in the longitude between B and the point Q. Okay? That's the difference in the longitude between those 2 points. So we were attempting A. So B now. B, we are being asked to find the position of Q. Now we've been told that this airplane starts off from B to a point Q. Okay? Alright? Now the question is, what is the position of Q? We know that the difference in longitude between B and Q is 9.9. How do we find Q? Now, what you need to look at is this longitude for B. Look at the longitude. The longitude is what? 70 degrees. Now, for us to find the difference in longitudes, there are 2 ways. You either add or subtract. Meaning that if we were to add here, then the difference in longitude should have been greater than this. Alright? So for us to get this, it means there was a subtraction that was done. Because we are saying to get the difference in longitude, you either add or subtract depending on the position. For the very fact that the difference in longitude is less than this one, then there was a subtraction that was done. If the difference in longitude was greater than this, then you would have realized that there was an addition that was done. So, meaning that we are saying since 9.9 is less than this one, then there was a what? A subtraction. And we subtract when points are on the same side of the meridian if it is longitudes. Not so. So we subtract when points are on the same side. Meaning that we'll say to get theta, you're going to say because we are saying the difference in longitudes between these two is 9.9. What we are saying is that we also realize that this Q is this side, all right? Because we are saying this airplane flew from point B towards the west, meaning that point Q should be this side, and somewhere maybe here, all right? Maybe in between there or somewhere this side. Meaning that if it is in between or somewhere here, then the degrees for Q will be less than the degrees for B in terms of longitude. So it means we are going to say this longitude minus the longitude for what? For Q, you get the difference in longitude, or which is theta. So we are going to say the longitude for B, which is 70, minus the longitude for what? For Q, which we don't know. It must give us this. So we are going to say 70 degrees minus the longitude for Q, which we don't know. But the answer here must be what? 9.9. I hope my explanation is clear. What we are saying is the difference in longitude is 9.9, which is less than this. If it is less than this, then there was a subtraction. So you must subtract. But now, how are you going to subtract? Are you going to say 70 minus x or x minus 70? This is what I'm trying to explain. Because we are saying this Q, this point Q is on the western part of B, meaning that it is this side. So in terms of degrees, the degree for Q should be less than the degree for B. And how do you find the difference in longitude in that case? You say this one, the bigger one minus the smaller one. So that's why we are saying, supposing that the longitude for Q is this, somewhere here, then to find the difference in longitude, we are going to say this longitude for B, which is 70 minus this one, which we don't know, we can call it X. Okay, so now we are saying, what is the difference in longitude, which is the theta here? It is 9.9 is equal to 70 degrees minus what? X. All right, so now what we are going to do is we are going to say this is the same as 70 degrees minus X is equal to 9.9. All right, then you say, I can even erase this so that we write nicely. Okay, so we are saying this and that is the same. So here you have negative X is equal to 9.9 minus 70. All right, degrees. Okay, so negative X is equal to 60.1. So you have negative 60.1 degrees. So you divide by negative 1 by negative 1. So X is equal to 60.1 degrees. Alternatively, at this stage you can say here, or you can say here, since there is a negative X here, when we take it to the left hand side, it will be positive X, which will be equal to 70 degrees minus, when you take this one to the right hand side, 9.9 to arrive at that. Okay, so what we are saying is, in terms of the longitudes, so this point, this longitude here, this longitude, all right, this longitude is 60.1 degrees, all right, but this is what? East. Okay, so that's what we have. So here, that's where our Q is now. Okay, that's where our Q is here. So now, how do we state the position of Q? You're going to say, to state the position of Q, you start with the latitude. What is our latitude? Our latitude is 35 degrees south. But now, what is our longitude? Our longitude is 60.1 degrees east. 60.1 degrees east. Please take note, even if they are mentioning about west, does not mean that the longitude will be on the western side. What will determine that is the difference in latitude. Okay, it's not always the case that because it is the west, then it should be west here, or because it is east, then it is east here. It is the difference in longitude that brings about that difference. I hope we have tried to explain these things. Okay, so that is how you get the value of, or the position of Q there. Okay, then the last question. The last question. Okay, so the third question. They're saying the diagram below shows points P, Q, and R on the surface of the Earth. So our pi is 3.142, and our radius, that's the radius of the Earth, is 6370 kilometers. Okay, so Roman numeral 1, we're supposed to calculate the difference in longitude between P and R. P and R, alright? So when you look at the longitude for P alone, the longitude is what? Is so for P we are saying the longitude is what? 55 degrees west, and for R the longitude is, maybe I use this, the same color, is 24 degrees east. So now to find the difference in longitude, you look at the positions. This is on the west and this is on the eastern part. So we're going to say difference in longitude, okay, is equal to 55 degrees plus 24. When they are on different sides, we add. Okay? When they are on the same side, we subtract. Okay, so here when you add, you have got 9. Here you have got 7. So this is the answer. That's the difference in longitudes between those 2 points, 79 degrees. Okay. For Roman numeral 2, given that the distance between P and Q, this one, is the distance between P and Q on latitude x degrees north. So the latitude here is unknown, it is x degrees north. Okay? So we're saying given that the distance between P and Q on latitude x degrees north is that one that has been given. So we are saying our distance, that is PQ, is given as 43. Hope you're able to see 92.079611 kilometers. That is the distance given between P and what? Q. So if that's the case, can we find the latitude? Okay. So now what we are supposed to do here is to look at P and Q, where they lie in terms of the position. So P and Q lie on the same latitude. Hence we apply the formula for finding the distance between 2 points on the same circle of latitude. So we are going to say, we know, let me write the general formula. So the general formula is theta over 360 degrees times 2 pi r cos x. This is the general formula. So now we are told that the distance that exists between these two is this one. So we just substitute. Okay? So here we have got 4,392.079611. Okay? Is equal to, okay, is equal to 2 times pi 3.142 times 34 times 34, 37 times, I can write here, say cos x. Cos x. So I can even write it here. So what we are going to do here, we can even introduce a dummy one. Okay. Okay, so let's rewrite this one. There's this part that is missing here. Alright? So we are saying 4,392.079611 is equal to there's this part that we didn't tackle here. The theta is the difference in the longitude between this one and this one, between P and Q, and the difference in longitude we got 79. Okay, there's this part here, we have left out this part. So take note, the theta is the difference in the longitude. So we have 79 degrees over 360 times now this part that is there. 2 times 3.142 times 6370 times cos x times cos x. I hope it is visible. So the whole lot of this one, we introduce a dummy 1. So even here we introduce a dummy 1. So what we are going to do here, remember there is 2 times 3.142 times 370 times cos x. Our interest is to find x. Okay, so we are going to say you multiply everything here. Okay? You multiply everything here, right? You multiply and get that. Do it. Then again, here you multiply, because the whole lot of this one is 1 here. Alright? So this one that is here will be multiplied by 1. We'll get this one. So you multiply this, the numerator, find the answer. Then again, you're going to multiply this here times the 360. Okay. So multiply this, we get the answer. So you multiply 79 by that. Okay, so when you multiply 79 by cos x, we are going to have 316297.32 times c cos c x is equal to, then again you multiply this times 360. So you're going to multiply this number here by 360. Because what we are trying to do is, if I have got 2 over 3 is equal to maybe x over 4. So that's why we are multiplying this, alright, with that. But here there is a 1, that's why we just ignored it. Then you multiply this. So in this case, you're multiplying this by that, which is this by that. Okay. So let's multiply this times that. Okay, I hope we are multiplying. So when you multiply, you'll get something like 158.65996. Okay, so now what we are going to do to find x here, we'll say cos x is equal to, we divide this both sides by this part here. So I'll say 158.114.8.65996. We are saying you divide this by this one because we want to remain with this part. Okay, so we divide both sides by this. So here we divide by 316297.32. Okay. Okay. Actually, if you want to find x here, instead of getting the answer, you can go straight and say x is equal to the cos inverse of this 158.1148.65996 divided by 316297.32. Now the question is, why have we introduced a cos? Because we want to remain with x. You can't divide by cos, it will be cos inverse. Of course, there is a way in which you can do it. So even if there was anything else, maybe tan, alright? If I told you are doing with such kind of equation, here to be tan inverse. Sine, it will be sine inverse. Okay? So here we are saying cos inverse of that. Okay, so that we get the final answer. Okay, so our final answer will be x is equal to, so x is equal to cos inverse of this. When you divide this, this is what you are going to get. And the answer here is 60.000006159. Of course, there could be some slight difference. All right, so remember we say for degrees we give it one decimal place. So this will be 60 degrees, 0 degrees. So in terms of x, this is what we are going to have here. That is our latitude. All right. Okay. So that was the Roman numeral 2. Okay. For Roman numeral 3, Roman numeral 3, we have to find the distance between QR. So again, you realize that QR lie on the same longitude. So we're going to say QR is defined by, the distance there will be defined by theta over 360 degrees times 2 pi r. Okay. Why are we using that? Because it is the same longitude. In this case, the theta is our angular difference or the difference in latitude. So the latitude now here is this, the 60. Here the latitude again is 60. So there are difference in longitude because this one is on the northern and this one on the southern pole. The difference is 120. You add. So you have got 120 degrees over 360 degrees times 2 times 3.142 times 6370 kilometers. Okay, we can even write the units at the end. So QR is equal to, so here we need to work it out. Okay, we need to work it out. So this is what we are finding: 133.026666. Of course, there are some numbers, you can write them in full. All right. So here our QR is equal to 3 significant figures: 1, 2, 3. Chop a line and consider 4 as 0. 0 plus this 3 here, we get a 3. Okay. So we have 1, 3, 3. Now there are 2 digits after the line and before the point, so I'll add this. This is in kilometers. And this is our distance. Okay, so that's our distance that exists between Q and the R. So that's all for this presentation, and let's see otherwise. Okay, so I can give you some exercise from the past papers. Can it be seen? This.
Okay, so you don't have to do like everything. For those of you that submit these questions, make sure that you just maybe do the first 2. You're given as many as possible just for your practice. Okay, thank you so much.